Hi students, this is Professor Watts coming to you from my house. I want to spend a little time and go over some of the present value, future value problems that we didn't quite have time to go over in class. Try to get you all set for the homework problems that are due next Monday and kind of walk through doing these problems and setting up the formulas in Excel. So first off, let me just take you to our Blackboard page and show you that, okay, if you're in Blackboard, and you come to course materials here, Unit 1, of course we're still in Unit 1. Okay, please notice I have all the PowerPoint slides put up there, and present future value Excel worksheet. Go ahead and open that on up. Now I've got it open on my computer already, so I'll click over to there. And notice what I have here on sheet 1 is future value of lump sum. Sheet 2 right here, present value of lump sum. Sheet 3, future value of cash flows, both mixed streams and annuities. And on sheet 4, present value of cash flows, both mixed streams and annuities. Okay, so first thing I'd actually want to do is walk you through the practice I would like you to do when you first download this spreadsheet. I have a simple future value of lump sum right here, a principal of $200, growing at 7% annual interest for 4 years. Let's calculate the future value. Now, right here where I labeled it future value manual, you'll notice I have just the formula typed in there. And of course, the formula for future value is, of course, the amount times the compounding factor, 1 plus the interest rate, to the power of the number of time periods. So it's the amount, the sum, times 1 plus r to the n. Okay, you'll notice that that's B3. That's the principal amount there, times 1 plus C3, 7%, the interest rate here, to the power of D3, the number of compounding periods there, future value of $262.16. Now, notice here when I say future value Excel, I want you to insert the Excel formula. We can check it against what we know is the proper formula entered by hand up there in up here in B5. So to do it in Excel, we're going to, remember, press Enter. FV, future value, open parentheses, and then Excel just simply has us do each component of the formula, the rate, the number of periods, the payment, the present value. Here, that's the $200, and the type, beginning or end of period. So the present, first off, the rate, that's found in C3. Okay. Then the number of periods, that's found in D4. Notice this time I'm clicking to select them. The present value is, okay, the payment is 0. We're only dealing with one initial sum of money, not payments over time. The present value is the $200, B3. And the type is the payment received at the end or the beginning of the period. We're always typically working with end of period, so we'll put in a 0 for that. And bada boom, it's 262.16. Now it reports the opposite sign of what your principal is, so we can correct that, remember, by putting a minus sign before our FV. Let me go to this, format it so it's the same font size as what we were working with up above. Okay, there we go. That's all there is to it. Let's review present value of lump sum. All right, this time we've got $200 that we're receiving 4 years from now. Let's discount that by 7% and see what the equivalent value in current dollars is. Remember, here we are investing $152.58 at 7%, so that in 4 years' time it will equal $200. Now, again, the formula here, the formula for present value, this is opposite of calculating future value. We can say we are undoing future value. So how do we undo when future value, remember, is multiplication right here? Future value, I'm sorry, present value, undoing future value will be division. So it's simply going to be the amount, there we go, divided by the compounding factor, 1 plus the interest rate, to the number of time periods. And note that here, that's what I'm doing. Present value manual, it is simply input here is B3, the amount divided by 1 plus C3 to the power of D3, the number of time periods. Okay, 152.58. Now, let's use the Excel formula, and again, we'll check it against what we know is the correct formula that I entered here, PV manual. So in Excel, we're going to do this equals PV, open parentheses, and again, we go through and we want the rate first. The rate is C3. The number of periods is D3. Selecting these and pressing a comma each time. The payment is 0. This is a lump sum, not an annuity. Comma, the future value, we know we're going to receive that $200 in the future. That's B3. And the type, end of period, again, close parentheses, enter 152.58. It keeps changing the sign on us. Let's undo that by putting the minus sign there. And bada boom. Once again, we have used Excel's built-in formula and just let the Excel do all the work for us. Okay, nice and easy. Now, here we've got the cash flow stream. Right, and remember, there's two things we can be dealing with. We could be dealing with a mixed stream of payments that vary. Here we get $400 at the end of year 1, $800 at the end of year 2, $500 at the end of year 3, $400 at the end of year 4, $300 at the end of year 5. Right, the manual way to do this is to simply take the future value for each payment. Okay. Now, since we're looking for the future value over a series of payments that last 5 years, the payment we get the first year, the $400, will earn interest for each year after the end of the first year. So we get that $400 at the end of the first year, so it earns interest for the second, third, fourth, and fifth year. 4 years. Okay. So we're going to take the future value of that to the fourth, compounding by the interest rate here to the fourth power. Okay. Second year's end of period payment is compounded to the third power right there. The third year is compounded to the second power. The fourth year compounded to the first power, and the fifth year not compounded at all. It doesn't earn interest. We get that exactly at the end of the fifth year. Okay, then I simply add those up. Now, Excel can do this for us. First of all, if we turn the future value of this series of payments into a net present value, we do that with the Excel net present value formula, which is right here. We enter in PV the rate, C9, and then value 1, value 2, value 3, value 4, 5, and so on. We've only got 5 here. The values are C3. These amounts here, C2, C3, 4, 5, 6, and 7. Okay, so we find the net present value, which is $1,904.76. Now let's do the future value in Excel. This is simply going to be, I'm going to put the minus sign in, the minus future value of the rate of 9%, number of periods of 5 right there, the payment. Here we've found a present value already, so we can put 0 in for that, and the present value is what we calculated. Type always 0, close parentheses, and lo and behold, we see that we have the value here, 2930.71. That equals what we calculated manually. Future value of cash flow stream annuity. Every year for 5 years, we get $1,000 at the end of the year. This is pretty easy. The formula, future value of an ordinary annuity is where you get the payment at the end of the period, is simply the payment times compounding factor 1 plus r to the n minus 1, and all of that is divided by the interest rate. We'll just take that formula for granted and we plug that in. All right, that's what I've done there. But we can also use Excel to do it for us. Okay, that's kind of complex and it's hard to make sure you get that right. Well, let's just use Excel. We're going to insert the Excel formula, equals minus future value rate right there, 7%, cell I4, number of periods right there, 5, cell I5. Payment, now we've got a payment, $1,000 each year. We enter that I3. We don't have a present value. We're starting with nothing, so that's 0. And we're end of period ordinary annuity, so that's 0, close parentheses, and lo and behold, we match. 5750.74. So we've reconciled doing this manually with the simplified formula in Excel. Okay, let's finally move over and do this again with present value. Here's present value of a mixed stream of payments, 4,000, 8,000, 5,000, 4,000, 3,000 received over 5 years. Okay, the manual way to do this again is to take the present value of each of those individually. The first one discounted for 1 year, so discounted to the first power. The second one discounted for 2 years, third one for 3 years, fourth one for 4 years, fifth one for 5 years, and so on. Then add up all of those individual present values of these sums in their own discounted values. Now, easy way to do it with Excel, we've actually already did this in the last sheet, is the NPV function minus NPV, which is net present value. And then all we have to do here is enter the rate and then each period future value cash flow payment in order. Whoops, comma, C5, C6, C7, close parentheses. There you go. That matches that. So we know we entered the formula correctly. We can always check it against what I did manually here. Right, let's look at the present value of a cash flow stream, the present value of an annuity. We get $7,000 a year for 5 years at 8%. The present value of this manually is using the formula here. Okay, so the present value here of an annuity equation looks like this. Present value equals the payment divided by the rate times 1 minus 1 over 1 plus r to the n. So that's a pretty unwieldy formula. I actually have entered that formula here. It's very painstaking to enter a formula like that in Excel. There we go. You can see this big mess of stuff up here. It's hard to know you got that right. A lot of parentheses, a lot of order of operations, complex. So again, let's just do Excel. Let's let Excel do the work for us. Equals minus PV of rate, 8%. Number of periods, 5. Payment, 7,000. Future value, here there's no future value. There's just the series of payments, so that's 0. And end of period, designation 0, close parentheses. And what do you know? We match, so we're correct. So we know that's good, that matches with that. Okay, so very good. So there's a review of doing our present value and future value formulas in Excel. Very, very important for you to know. Now, homework assignment here, and I noted that we were going to do a few in class. We didn't get to that. That's the main reason I'm bringing this video to you. So let me go into the book here. I got the book right here. And let's take a look here. I said I wanted to do 312 and 319 in class. Maybe we'll do 1 or 2 others. Right? I liked 312 because it was a very practical kind of problem. We can start to see where the relevance of using present and future value calculations. I'm setting this up just like it appears in the book. The book says, problem 312, Ruth Nail receives 2 offers for her seaside home. The first offer is for $1 million today. The second offer is for an owner finance sale with a payment schedule as follows. Okay, end of year 0, which means today, she will get $200,000. Widen that cell so we can see that number. Okay, end of year 1, 1 year from now, she's going to get another $200,000. End of year 2, she's going to get yet another $200,000. Notice how I can drag and drop that. End of year 3, yet another $200,000. End of year 4, yet another $200,000. And at the end of year 5, a balloon payment of $300,000. Okay. Now, if you naively just add up these numbers, let's do that first. You might think, this is worth the sum of these numbers, $1.3 million. And the other offer was for $1 million. $1.3 million is bigger than $1 million, right? Well, no, because this is future money, and future money When we discount to the present, we find that present money is worth less than the same amount in the future because of compounding over time, right? So we don't want to forget about just adding this up, and what we need to do is calculate present values. Right, now there's a couple different ways we could go about this. We could just say present value of each payment, and then add them up. And that wouldn't be that hard to do. You know, we could just use Excel, present value. Now, rate. Oh, what's the rate? Let's see. The book says, assuming no differential tax treatment between the two options and that Ruth earns a return of 8% on her investments. That's what we use for the rate. So I'm actually going to put that in. I'm going to put that over here. Escape. I'm going to put that over here. R 0.08. Haven't formatted that as a percent, so I have to put it as a decimal. Okay. So we could say present value of this amount right here. Of course, that's already current, isn't it? That's money today, so we don't need to calculate that. We just need to write it down, 200,000. Okay. Now the present value of an amount 1 year out at 8%, there we have to calculate. That equals present value rate. Grab that down here, 8%. Number of periods, that's that 1 year and in the first year. Payment, no payment, just an amount, 200,000. Future value is 200,000, and it's at end of period, so value 0 there. Okay, it's 185,000. Oh, that pesky Excel changing sign. Let's change it back. Okay, that's only 185,000 when we discount. Same thing here. Rate's the same. Number of periods is now 2. The payment is still 0. Future value, of course, 200,000. And the type is 0. Oh, yeah, I've got to change the sign. Once again, the third year payment equals negative present value rate 8%. Number of periods is now 3. Payment is 200,000. Nope, payment is 0. Future value is 200,000. Type is 0. All right, let's do that again. Negative present value rate 8%. Number of periods now 4. Payment still 0. We're treating this as a lump sum, so that's future value of that, and that is 0. And finally, the present value of the 300,000 balloon payment, negative present value rate, number of periods, payment 0, future value 300,000, type 0, close it off, and we can, let's put a line under this, equal the sum. We can add up these amounts, and we see, oh, it's only up 1.0. It's only 1,066,600. Now, still better, and that's in present value terms. So that's the series of payments, even though it's in the future, and the present value is less. It's still greater than the $1 million that the other offer is. So it's still worth taking. Now, what I showed you was a tedious way to do it. An easier way to do this, because the first 1, 2, 3, 4, 5 payments are the same, that looks an awful lot like an annuity. So what we could do is just say we could have the present value of that annuity for the first 4 years. And actually, we could take the amount today, that's already in present value terms. So that initial amount here, we could just bring that right over. Let's actually do that. Control C, Control V. Just paste that. Okay, these amounts here, the 4 payments of 200,000, are just like an annuity for 200,000. So we could do that. We could just say that equals the negative present value of rate, rate 8%, number of periods 4. Payment is now 200,000. Future value 0, because we've already plugged in that this is a recurring payment, and the type end of period. Okay, so we do that, and the sum of those is 662,000, and then this we'd have to individually take this as a present value, negative present value of rate, number of periods is 5, payment is 0, future value is 300,000, we've already done this, payment is 0, there we go, future value is 300,000, type is 0. And now we again add these up, and we get the same answer, a little bit easier, fewer steps. There's one way to do it that's even a little bit easier, which is if we take a net present value. Okay, net present value rate, comma, and then payment 1, 2, 3, 4, 5, close parentheses, and add in, remember, our initial 200,000 here, because it's not discounted at all. Control V, put a line under it, add those together. So all I did there was showed you 3 different ways to use Excel's formulas, and we can really lighten the workload and let Excel do all the work for us, as long as we know what's going on here. Okay, we're discounting payments that we receive in the future, except for this first one, that occurs now. These all are discounted in the future. We could do them individually, like I did here. We could treat it as one 4-period annuity plus a lump sum, or we could treat it as a net present value problem, which is probably the easiest, although you have to be the most knowledgeable about what's going on to make that one work. Okay, notice the answers are always the same, so we can check ourselves and make sure that we're doing this right. Okay, so that's problem 312. Let's look at one more. Let's look at 319. 319 is a fun one because it's going to introduce the concept of a perpetuity. Okay, so what's going on with the perpetuity? The formula for a perpetuity, okay, this is a payment that you receive forever. You want to think about it in these terms. The present value of an ordinary annuity, remember the formula is this, it's payment, the amount you get each year, divided by the interest rate, times this discounting formula, which is 1 minus 1 over 1 plus r to the n. Okay. If this is a perpetuity, meaning you get this payment every year, that means n is infinity. Okay. What if the n figure here is infinitely large? Well, we take whatever this number is to the power of infinity. That makes this whole thing here's a mathematical term for you, a honking large number. Okay, we take something to the infinity power. That makes this whole thing a huge number. 1 divided by infinity is what? A very small number. 1 divided by that. So this whole thing is a tiny, minuscule number. It's essentially 0. So then this whole discounting factor over here, 1 minus essentially 0, that means this is 1. So we're taking a payment over r times essentially 1. Of course, anything times 1 is itself. So the present value here of a perpetuity equals just the payment over the rate. Okay? So with that in mind, let's work this problem. And the problem, which is 319, the problem says this: Matt Sedgwick, Facilities and Operations Manager for the Birmingham Buffalo professional football team, has come up with an idea for generating income. Matt wants to expand the stadium by building skyboxes sold with lifetime, perpetual season tickets. Each skybox is guaranteed 10 season tickets at a cost of $200 per ticket per year for life. If each skybox costs $100,000 to build, what is the minimum selling price that Matt will need to charge for the skyboxes to break even if the required return is 10%? Okay, so how much do they have to sell these skyboxes for to break even? The required rate of return, let's go ahead and put that in first. R, 0.10, 0.1, 0.1 or 10%. The raw cost is 100,000. You might think, well, that's the present cost, so as long as they sell it for 100,000, they're breaking even. But it says that each stadium comes with a guarantee for 10 season tickets costing $200 each. The tickets equals 10 times $200 each, so $2,000. Okay, so the tickets cost the football team $2,000 a year. And what this represents is that the team could have sold these tickets to somebody else if they didn't guarantee them to the Skybox purchasers. All right, so what we have to do, and that goes on forever, so what we have to do is find the present value of those tickets. And that's going to simply be the perpetuity because they go on forever. So that equals the payment, which is D29, the ongoing value of the tickets, divided by the discount rate, which here is D25. Okay. So the value of the tickets on perpetuity is $20,000. So what's the selling price of the stadium or of each Skybox? It's got to be the $100,000 plus the $20,000. They've got to sell these things off for $120,000. Okay, that covers the present value of the $100,000 for building each Skybox and the present value of the ongoing perpetuity of the loss of $2,000 worth of season tickets that they guarantee to each Skybox owner. Okay, you can see how these kind of problems, whether we're talking about receiving payments over time, whether we're talking about covering costs that might be incurred over time, you can start to see how this becomes very relevant for business planning purposes, right? And knowing your present future value and being equipped with the knowledge of calculating present and future values, especially in the spreadsheet, is crucial for your future success. So I'd recommend you really study up on this, and you'll do well in the homework. You'll be all set for the exam next week. All right, until then, signing off. See you next time.